Right, guys, welcome to the lecture. And I think in the previous lecture, we have seen only the basics of array. We have not seen anything big, just the basics of array, how array can be declared, how values can be initialized, and how using index, how we are going to access all these things only we have seen. In the memory block, how array is stored, only these things I have shown you. One thing that I left in the array is that I need to show you one more thing. For example, if I just declare an array of size 5, for example, and I have to store, I'll be storing, for example, I told you that this place itself you will be able to assign, right? So what I will do is I have taken 5 block, and 5 block, what I have to do, 5 elements. But there is no necessity that you have to give 5 elements. You can also give uh, two. I'm just giving only 3 elements, 2 elements shortage. 2 elements I'm not providing. If 2 elements are not provided, then we will just check what will be happening. Okay, so now just for the sample, just for the demo purpose, I'll just print what is there in a of 2. What is there in a of 2? In the second index we are having the element called 4, because the very first element belongs to 0th index, next element belongs to 1th index, and the next element belongs to 4th index. Okay, just by saving this, I'll just show you the background process. I'll show you the line by line process happening inside the compiler. Fine. So can you able to see here, one activation area is created in the stack, and one block for A with 5 blocks inside is created, and all these numbers are having some random values. Let me execute this fourth line. Fourth line is executed. Can you able to see the first 3 elements are allocated with the respective element that I have given, and the remaining 2 elements have become 0. So what becomes is that if you at least assign one value at the time of declaration itself, when you assign 1 or 2 values, all the remaining values will become automatically 0. By default it will be garbage value. But if you assign at least one element, don't go to 3 elements. If you assign only one element, that 0th index element will be assigned to, and all the other elements will be assigned to 0. Okay, so suppose if you want to assign okay, so that we will just, I'll show you that also. For example, I am just assigning only 2, and we will check now. We'll check now here. So if you see, it's random elements are only there, 40505, some garbage values. Suppose if I execute fourth line, first element is changed to 2, but all the elements, if you see, these elements are changed to 0. So once you assign at least one element, and all the other elements will be changed to 0 only at the time of declaration. I'm not telling like this. If you do like this, okay, I'm not telling like this. Okay, so if you do like this kind of initialization, a of 0 is equal to 5. If you do like this, this is not going to assign all, this is not going to change all the other elements to 0. Only this kind of declaration, the declaration that comes along with the initialization, that comes along with the declaration, this only what it will do. At least one element, if you assign, all the other elements will become 0. So if I want to allocate all the elements to, if I want to change all the elements to 0, what I can give, I can simply give 0. So what will happen, the 0th index will be stored with the 0, and automatically all the elements will be converted to 0. So if I give like this, what will happen, all the 5 index element will become 0. It does not mean that this 0 is allocated to all the places. No, this 0 is allocated only to the 0th index. All the remaining index are changed to 0 automatically. Okay, so I can also show you that. Okay, just let me stop, and I'll just show you again now. So now, because of this implementing 0, okay, here extra bracket I have given. Okay, just let me save. So if you see, again random values are there. So if once I execute, all the index elements have become 0. Okay, fine. So this is one thing that I left, the basics of arrays. Okay, so now we will just enter into structure. Okay, I'll just stop this process. We will enter into structure. What is the structure? First, I will just go with implement. I mean, to the just general explanation, definition. Then I'll just tell you manually for what reason we have to go for structure. Structures are collections of data members. Data. It is also collection of data. So we generally say that the collection of data member of related under one another, of related data member of related under one name, and the data type can be similar. The data type can be similar or otherwise dissimilar also. This is one kind of advantage. What we are saying, collection of data member of related under one name, and those data can be either of similar data type or dissimilar data type. Coming to array, we said very clearly that it can be of the same data type. If I want to cluster 5 elements of the same integer data type, then I can go for array. If I want to, for example, I'll just tell you a few examples. For example, you can just take array. You can just take mark of a student. We know very well that a mark of a student will be definitely integer. A particular student can have, for example, 5 subjects. When 5 subjects are there, and each subject will have 1 mark, so you will be having 5 integer values. So when 5 integer values are there, you can cluster it together in array, because all these 5 marks are of same data type. But suppose, I'll just tell you, if you want to, we'll take student database. For example, if you see student, a student can have a name. He can have name, and he will have, for example, age, and he might have, for example, marks. Okay, then CGPA, address, and many other data also. For example, we'll just take these 4. For example, if you take names are characters, collection of characters. We call it as strings. It's a different data type. Age will be integer. Marks will be integer. CGPA will be a float value. So all these data are different data type, different data type, but they are of different data type, but they are all related data to a particular entity. They are all data associated with a single entity called student. Okay, so take a object like student, and what are all the details of the students can be clustered together, and that is what the usage of structure is. So related data member can be considered together. I'll just give you a few examples for your better understanding, but this is a thing that I want to convey. Structures are used for collectively store the data members which are related to one another, which are related to the same entity, and they can be of similar data type also, no issues. We will not say that this has to be of different data type. No, same data type also is fine. The same mark can also be taken as a structure, because you have 5 subjects, right? And all these 5 subjects marks are related to only one student. These all 5 subject marks are related to one student. So all these 5 subjects are going to be subject 1, then subject 2, then subject 3, then subject 4. For example, so 4 subjects are there, and all these 4 subjects marks are related to a single entity called student. It is related to one another. So these 4 integer data can be same data type. So these 4 integer data can be also clustered here in structure also. Okay, so but one difference is that in array, I will not be able to store different data type collectively, but I will be able to do it here in the structure. But the main motive of structure is not to collectively store different data type. Okay, the main aim of structure is not to store different data type, but to group the related data members. What are related data members? This data members are related data members because these are all related to a same entity called student. Okay, for example, we will just take a example of rectangle. I'll just take a rectangle. This is rectangle. For example, this green color marked is a rectangle. So rectangle is the entity. And what are all the data that is related to rectangle? I think length and breadth. Hope you know this, right? So length and breadth are the two data that are related to this particular entity. So what you can do, you can take this as a structure. How we are going to take this as a structure, that I will show you here. Okay, so a structure has to be defined outside your main function. A structure has to be defined outside the main function. Here in this place, cursor blinking, right? That place. So first of all, you will have a keyword called struct, followed by the name. What is the name? I think these two data member are related to the entity called rectangle, right? So we can keep this entity name as the name of the structure. So we can take rectangle as the name of the structure. Inside this, I will open a body part block, open curly braces and close curly braces, and inside this open and close curly braces, I will enter the data member. What are the data members? One is length, and length will be an integer. I'm just taking it as an integer. So int length, followed by what is one more thing? One more thing is going to be breadth. Fine. So this is a rectangle, and rectangle will have length and breadth which is clustered together inside a structure. So whenever related data members are there, then you can take it as a structure. So now for example, I will tell you, if you take integer will take, for example, we told that either 2 byte or 4 byte based on the compiler. Okay, and one more thing I need to tell you, and this complete definition should be ended, right? So this end should be ended using a semicolon at this place, outside this close curly braces. Next to this close curly braces, you have to give a semicolon. Suppose if you are not giving the semicolon, can you able to see that this bracket, this place is showing an error? Because this place is expected to print it is expecting a semicolon. So once you give the semicolon, automatically the error is taken back. Okay, now if I just see integer, you know very well that integer will take 2 or 3 4 bytes. Okay, integer will take 2 or 4 bytes of data based on, it will take 2 or 4 bytes of data based on the compiler. Here, for example, let me consider that integer is taking 2 byte. Suppose if integer is taking 2 byte, then how much memory this entire structure will be taking? How much memory this entire structure will be taking? This will be taking, for example, this integer length will take 2 byte. Let me assume that integer is taking 2 byte. And now this breadth will take 2 byte. So if you add all this byte together, this entire structure will take 2 plus 2 equal to 4 byte it will take. Okay, so this will take 4 bytes. Fine. So this is one thing that you should know, how much memory is allocated. And one thing, while defining the structure, the memory will not be allocated. Only while initializing, only the memory will be allocated. Only during the initialize, only if you are declaring some variable using this structure. Suppose if you are declaring any variable using this structure, then only memory will be allocated. This 4 byte will be reserved. Now while you are defining this, declaring, right, in the definition part, definitely it will not be working. Okay, definitely this is not going to occupy any memory. Now it will not allocate any memory. I'll tell you when it will be allocated. So in this video, what I have planned is, I have to tell you how defining structure. It's the first one. The next one is, I have to tell you about the size of structure. How it is going to be the size of structure, based on what we will be calculating the structure of size of structure. Then followed by declaring a structure. And next we have to do how to access the data members. So accessing the member. What is member? Each and every variable inside the rectangle structure is called member. So length is a one data member, or generally called as member, and breadth is called as one data member of the structure rectangle, generally called as member. Okay, fine. So how to access the member inside the structure, how to declare a structure, defining structure, size of the structure. I think we have finished the first two parts. Defining structure, how to define a structure. We can take a entity, and this entity we will have certain related data, and those related data are converted to data member, and the entity is converted to structure. You have to place a semicolon at the end of the definition. So this is completely called as defining the structure. And size of the structure, whatever the member is, each and every member's corresponding how much memory will have to be taken, and it has to be added, and the total memory is what the memory allocated to rectangle, and that is what size of the structure. So what is the size of a structure? Size of the structure is sum of the size of each and every data member. Okay, so size of the structure means it is sum of the size of, okay, sum of the size of each and every data member. So 2 plus 2 4, it is what size of a structure. Now the next thing is we will just come to the part of declaration. Okay, how we are going to declare it. Okay, so I'll show you here itself. How I will be declaring is struct keyword followed by the name of the structure that you have provided. So now what I have to tell you is that similar to integer, now this entire word, okay, similar to integer data type, now struct rectangle itself becomes a keyword. Struct rectangle itself becomes a keyword, and it becomes a new data type that a user has defined. You have defined, the system has not defined. C language is not defining, you are defining a new data type. So that this is called as user defined data type. I think in the data type section I have shown you certain classification. Among those classification, one classification is user defined data type, and inside that only rectangle and union was coming. Okay, so not rectangle and union, structure and union was coming. So this is a user defined data type. We are defining a data type. Okay, so now what happens, my struct rectangle, the keyword together, struct rectangle itself becomes a data type. So first of all, whenever I want to declare a variable, what I need to do, I need to specify the data type of the variable. What is the data type of the variable? Struct rectangle. Struct rectangle together is called as a data type. So now data type, with this data type, can I declare a variable? Yes, let us declare a variable called R. So I told you that when I'm defining the structure, memory will not be allocated. Now whenever you are declaring a variable, here only memory will be allocated. Now only memory will be allocated. Memory is allocated now. How memory is allocated, that I will show you now. How many members are there for rectangle? Only 2 members are there. So let me show you here. For example, these 2 blocks are allocated. For example, I'll just show you these 2 blocks. These 2 blocks, consider that these 2 blocks are allocated. Okay, so first block will tell you, it is referred to the member called length. This first block is allocated for length, and the second block is allocated for breadth, and these 2 blocks are consecutive blocks which is allocated. So this entire thing is called as a struct rectangle, and this entire memory block is given the name called R. This entire memory block is given because I always I am again and again telling you, variables are the name given to the memory block. So for struct rectangle, what you have done, for struct rectangle, you have created a memory block. In that memory block, one part is length, first data member, second block is breadth, is the second data member, and this entire part is given the name called R. This memory blocks, both these memory blocks are given the name called R. Okay, so now the next thing is we will just go with we have done declaration. Right now we will go with initialization part. Okay, so now I'll just come here. This part can be called as declaration part. This is called as declaration. And now I'll just show you one more way of doing the declaration as well as the initialization in the same line itself, as I showed you for the arrays, right? I showed you for the array. How I showed you for the array? I showed you like this. Okay, int a of 5 and is equal to open close curly braces 1 comma 2 comma 3 comma 4 comma 5 semicolon. This is the way I told give you, right? Declaration as well as initialization, both are coming in the same line. Similarly, here also this can be converted to, this is declaration and initialization can be given like equal to open curly braces close curly braces, and for example I'm planning to give 10 comma 5. Now what will happen? Your first member of the structure data type is length. That length block, that length data member is allocated with 10 and breadth is allocated with 5. Okay, so now what happens automatically when you give like this R block is created, and in the length block 10 is stored, and in the next block breadth block 5 is stored. Okay, fine. So now this is declaration as well as initialization coming in the same line. Suppose I'll just comment this. Suppose if I want to do the declaration and initialization separately, like in array. In array, what you did in array, you declare in first line, and also what you do in the next line, a of 0 is equal to 10, and then a of 1 is equal to 10. You did your initialization like this also. Am I right or wrong? Yes. So I told you that this is the way to access the array element, and this is called as, the entire part is called as initialization. So declaration is happening on the separate line and initialization is happening on the separate line. So like this, similar to this, I will show you one more way in rectangle also, sorry, structure also. So first of all, I have to declare a structure rectangle, and variable name is r. And now if you see, variable r dot length, where dot is the operator which is used to access the data member of a particular structure. So r is a variable of the structure, and using r I can able to access the member of the structure. So what will happen now? R dot length is equal to 15. Then r dot breadth, I'm accessing the next member and I'm assigning 10 to it. Okay, so using this dot operator only, what we are going to do, we are going to access the member of a structure. You might think that while I'm assigning these values, automatically these values are assigned here. No, the values are not assigned here. The values are assigned to the new memory block which is created, this block. In this block only memory is, the value is stored. So for example, r dot length is equal to 15, r dot breadth is equal to 10. What will happen here? Automatically this will be changed, 15 and 10. Suppose for example, I take one more rectangle, and the name of the rectangle is, for example, I'll just take temp. And now what I will be doing is, I can see whenever I declare a new variable like this, what will happen? A new block will be created. For example, like this, a new block will be created like this, and this is a different block. This block and the previous block, this r block and this temp block, both are different block, both are not having any relation. First block refers to the length and second block refers to the breadth. This block refers to the length member of temp. This block refers to the breadth member of temp. This block refers to length member of r, and this block refers to breadth member or r. So both are different. So now for example, if I give temp is equal to 3,8, what will happen? This new block which is created here, 3 will be stored and here 8 will be stored. Yes. So now I'll just show you the same thing. Okay, fine. I'll just show you the same thing here in this main memory also. I told you in main memory what will happen whenever your main function, which is the entry point, whenever your entry point is starting to execute, what are all the memory block required inside this main block. First of all, a main activation area will be created, and inside this main activation area, whatever the block required will be allocated inside that activation area. So what will happen here, one activation area for inside your stack will be created. Okay, so for example, one activation area for your stack will be created here in the stack, and the activation area name is main activation area. So inside this main activation area, what will happen, two block will be created. One block is R, and R will be having two different block, one is length, the other one is breadth. Similarly, you will have one more block called temp, and this also will be having two blocks. One block refers to length, the other block refers to temp. So what will happen when you assign some value to this R will be for assigned 15 and 10, for example, 15 and 10. So similarly, what will happen is the temp will be assigned with 3 and 8 once you assign, I'm telling. Okay, so now what will happen, once the entire program is completed, then the activation area, then this entire main activation area will be deleted, and all the code which is stored in code section also will be deleted. Okay, so I'll just show you the background process of the structure here line by line also. Right, so if you see here, you have two blocks called R and temp. So first of all, activation area called main is created inside your stack, and inside that activation area you have two blocks called R. Let me expand this block called R. What you're having two member called length and breadth. Inside temp you're having length and breadth separately. Okay, so it's separate block for R, separate block for temp, and it is having a random value, I mean garbage value. Don't think that any 5 is assigned. No, 5 is not assigned, 4 is not assigned, 0 is not assigned, 0 is not assigned. They are all garbage values. So now I will execute this 15th line. If I execute 15th line, what will happen, R blocks length member will be changed to 15. We will just check. Yes, it is changed to 15. Now if I execute 16th line, then the same R block breadth member will be changed to 10. Yes. Now similarly, if 17th line is executed, what has to happen, the temp length and breadth has to be changed to 3 and 8. Yes. Now once the last line of the entire program is executed, and what has to happen, then the entire variable section, stack, everything is deleted. Okay, fine. So now if I have to print it, what I have to do, printf, you have to print the integer value, right? Two integer value, for example, I will just consider %d, comma. If I want to print the length and breadth of rectangle R, then I have to print r dot length, comma, r dot breadth. So how will you access? Using the dot operator. So variable dot the member of the structure that you need to access. Okay, so what we have seen so far in this, so I'll just make a semicolon, and I'll just also show you how we'll just execute and check whether this is working or not. Yes, can you able to see here, r dot length is 15, r dot breadth is 10, both are printed. Yes, so in this section what we have seen so far is we have started structure, and I've shown you that structures are collection of data member of related under one name. For example, only I just showed you the case of marks of a student, and as well as also detail of the student. Okay, the data might be also similar, as well as also the data can be dissimilar also. But if the data are related to one entity, then that can be taken as a structure. Then followed by that, we have seen 4 things: defining a structure, size of structure, declaring a structure, accessing the member. How to define a structure? You mention the keyword called struct, followed by a name given to that structure, and you open a curly braces, close a curly braces, whichever coming inside is a body of the definition, and inside the body of the definition we have to specify the data member. What is data member? The members that are related to this particular entity called as rectangle. Then we wanted a semicolon at the end of the definition, so definition part is over. And then coming to the size of the structure, we simply said that sum of the size of each and every data member together is called as the size of this entire structure. So the size of this first member is 2, size of the second member is 2, so adding both these 2 we will get 4. So the size of structure will be 4. Then coming to declaring a structure, then comes here. So similar to integer, struct rectangle also becomes a data type, independent data, user defined data type, and we are specifying the data type and we are declaring a variable called R. So once you declare a variable, what will happen? I showed you here that a memory will be allocated like this, and one block is having, so how many block will be allocated? How much member I am having, that many block will be allocated. Okay, inside this block 15 is stored. It means integer means 2 bytes. So inside this block is of 2 byte, this block is of 2 byte. So such a memory is allocated, and this memory block is given the name called R, and it is having 2 member called length and breadth like this. Next, what is the next one? Accessing the member. How to access? Using the dot operator. So the variable dot the member. So this is a way how you have to access the member of a structure. So two way of declaration and assignment is there. One thing, you can declare it independently, and the subsequent line like this you can make initialization, or otherwise like this you can give the declaration and the initialization in the same line itself. Okay, so far this much thing we have completed. So in the next video, which is coming in 5 minutes again. Okay, so now I think we started the first session by 10 o'clock and it finished by 10:40, and now again 10:45 we started this session, and this session has went up to 32 minutes of time. So automatically what will happen now, 30 minutes in the sense it is like 12:05 or 12:10 it will be finished. So what we will do is again from 12:15 we will start the next session. So from again 12:15 we are going to start the next session, and in the next session we will be seeing few examples. We will take few examples and we will define a structure for all those examples, and also we will see how to convert structure array. One more concept called structure array is there, where the structure variable itself will become an array. Okay, so we will see about that might be confusing now, but we will see that in the next video. So we will see that, and in the next lecture we will also see about pointers, the introduction to pointers. Okay, see why we require all these things is that I am going to teach you function. If you need to understand function, then you need to understand the basics of arrays, only the basics of array, and you have to know the basics of structure, and also you have to know why pointer is required, what is pointer, and how it is going to work. So when basics of three concepts are over, then we can get into function and we can understand many things about function. Okay, we have not finished array, we have not finished structure, we have seen only the basics of it. Okay, so in the next session we will see a little bit more about structure, and we will just see about pointers, and once pointer is finished we will just go to functions and we will just finish functions. Okay, so once we finish functions, then we can start fresh from array and we can convert array into abstract data type. That we will see later what is abstract data type, everything. Okay, so we are having a flow actually, right? Okay, so this flow might be different, but this is the right flow for you to study. Okay, fine. So hope I'm not teaching you anything. I'm just teaching you the concept, and if I'm teaching a structure, then all the prerequisite which is required to learn structure I could have finished it in the prior video itself. Okay, if array has to be taught, then the prerequisites of array will be completed. So similar to that, if I have to teach a function, then all the prerequisite required to teach function has to be taught, right? So that only I'm doing now. So I'm teaching you the things that is required to make you understand functions better seen so far. And now followed by this, we will just take three examples and we will convert these three examples into a structure. The very first example is just I'm going to take complex numbers. What is complex number? A complex number is a number which is in the form of a plus ib, where I is equal to square root of minus 1. I is equal to square root of minus 1. So we can say that a is the real part and b is the imaginary part. So taking a complex number, we have two data. One is a, unknown data a, and this a is called as real part of complex number. In mathematics we could have already learned this. Okay, b is going to refer to imaginary part, right? So now what I can do is that here the entity is called as complex number and the data member are real part A and real imaginary part B. So these two data are associated with a single entity called complex number. So how can I define it as a structure? Actually, first of all, a keyword called struct followed by the name. Let me take it as complex. Okay, complex number, like this, complex number, then followed by the body part, initialization, declaration part, defining part. And inside this I can take two integer value, because real and imaginary, let me assume that it is real, integer. So integer real, first part, a part, and then one more part is integer imaginary. So hereafter, instead of just declaring int real, int imaginary, or a plus ib format, if you want to represent anything, you should not, you no need of going to the going and just declaring like this. Don't go and declare everything separately like this, int real comma imaginary. Declaring like this, you cannot understand this real and imaginary means. Suppose you might have 5 or 6 complex numbers. When 5 or 6 complex number is there, what you will do, you will write real 1 imaginary 1, real 2 imaginary 2, real 3 imaginary 3. So this will become confusing. So it is not an organized way of writing a code. For organizing it, only what I'm telling, when you found some data and if these data are related to a single entity, then don't declare it separately like this. Take this data, cluster it together and write it as a structure. Okay, so suppose if you define a structure like this, what is the size of the structure will be? The size of the structure will be the sum of size of the member. What is the size of the first member? For example, let me assume 2 byte. The second member, again 2 byte. So what will be the total memory? 2 plus 2, 4. 4 will be the total memory of complex number if integer is taking 2 byte and if integer is taking 2 byte. Suppose integer is taking 4 byte, then 4 plus 4 will be equal to 8 byte totally. Will be equal to totally 8 byte if integer is taking 4 bytes. Okay, so similar to we are not going to use this and we are not going to do anything, but I'm just showing you the defining part alone. I'm going to take few scenario and I'll write the corresponding structure defining statement. Okay, so we'll just take it off, and now again I will just tell you next example, and the next example is going to be student. What are all the data that is related to a student? For example, first one you can take a roll number, next his name, next one his department, and next one address. For example, your roll number, let me consider that the roll number is integers. Few people roll numbers are in string format also, character format also, but let me assume that a particular student's roll number is integer. Okay, the name will be definitely a integer, sorry, character. Okay, so it has to be of character array. Because why I'm taking it as character array is, you know already integer array I have shown you. Why I'm just telling this character array means, we told that a single character will be able to store only one single character, but name is not going to be one character. Name is going to be collection of character. For example, like my name is Sachin, right? So double quotes SACHIN, multiple characters, collection of characters are coming. So character array, when I want to store multiple element, collection of values, then what I need to go for? I need to go for array. When I have 5 integer, go for I have used integer array. Now when I'm having 6 characters, to collectively store 6 characters, then I have to come to character array. So character array we will see in a different part. Okay, just I'm telling you that name is going to be a character array. Character array we have a different you have a separate section. Okay, fine. So next one, coming to department like information technologies, computer science engineering, electronic and electrical engineering, it is also going to be a character array only. Okay, so this is also going to be a character array. Coming to address is also of course a character array. So now we will just convert this student scenario into a structure, and we will just see. So struct followed by the name of the entity, which is student, and inside the body I'll be taking integer roll number, so integer roll. Next one, it is going to be a character array. And what is the character array? Name. And what I told you, if you want to convert a variable into an array, then it has to be followed by a bracket, and you have to specify. So for example, let me specify 25. Let me assume that the name of the student is not going to exceed 25 characters. Then I will just take character, then it is going to be department. So the department name also I will just consider that it is going to be there in 10 characters. Within 10 characters I am going to write short forms, maximum 10 characters. I'm just assuming. Next, followed by address. So if I want to store address, let me consider that it requires 50 characters. So when I want to store 50 characters, the size of the character array is going to be 50. Don't think about how we are going to use this character array and all that, we will see later, but I'm just showing you the way to define the structure alone. Okay, so now at last we have to give the semicolon at the end of it. So what we have done, we have taken an entity, all the data related to entity are clusterly stored like this. You need not to declare it separately, like roll number, roll name 1, department 1, address 1, roll 2, department 1, department 2, address 2. No, you have to make it organized way, or that organized way of declaring it was called a structure. So what is going to be the size of this? So what is the size of an integer? For example, it is 2. What is the size of a character? Single character is 1 byte, but here totally 25 character spaces. So 25 character means each character 1 byte, so totally 25 byte. Coming here, 1 character is 1 byte, so 10 character means it is going to be 10 byte of data. 10 byte of data. Then again 50 characters here, so 50 bytes of data. So totally how much byte of data you wanted? 50 plus 10 60, 60 plus 25 85, 85 plus 2 87. So totally 87 bytes of data will be allocated. 67 bytes of memory will be allocated for this structure, not while defining but while declaring it as a variable. Okay, fine. So next, one more sample we'll see. This one more sample is going to be, the next sample is playing cards. Hope everybody knows playing cards. I think so. Playing cards. Okay, just I'll show you an image of a playing card. So if you see here in this image, if you see this image, just see in the same image itself. Okay, so we'll just see the same image. You will be able to see 5 cards, and I think everybody knows this playing cards, right? So coming to a playing card, if I take a card, what are all the data from a card? What are all the data member will be coming? I think one is the number which is there, number. So I can take it as like symbol. Okay, so this number can be taken as like face. Okay, that number part we will take it as face. What is this shape? This is shape. This is heart in, this is spade, this is diamond, and this is club, or called as clover. Number is called as face. The symbol, this shapes are shapes, we are going to say, take it as shape. And color, you have two different color, red color or black color. So these are all data which is related to playing card. Am I right or wrong? What are all the data that is related to playing card? First of all, playing card I'm taking. What are all the data which is related to playing cards? First one is face. Face means either A, it starts from A, right? A, 2, 3, 4, 5, 6, 7, 8, 9. No 10 is there. Okay, sorry, 10 followed by J, no 11, instead of 11, J, Q, K. So totally 13 faces are there. 13 faces like this are there. Then the next data member will be shape. How many shapes are available? 4 shapes are available. What are the shapes? Heart, followed by spade, then diamond, then followed by clover or otherwise club. Okay, clover or club. And then what is the third data? The third data is color. What are the colors available? Either red or black. Either red or black. So I take an entity, and what are all the data members related to it? Face, shape, color. So let me consider that the face, I'm going to take it as not a character. I'll just take it from 1 to 30 as an integer. 1 means it refers to A, 2 means refers to 2, 3, 4, 5, up to 10 it is okay, fine. 11 refers to J, 12 refers to Q, 13 refers to K. So we can have face as an integer value. Similarly, coming to shape, shape also we can take it as a integer value. For example, we will have 0, 1, 2, 3, where 0 points to heart, 1 points to spade, 2 points to diamond, and 3 points to clover. And I think heart is of red color, heart and diamond is red color, spade and clover are black color. Similarly, color also what we will do is we'll take 0 or 1. When 0 it is red, when black it is 1. So red is referred by 0, black is referred by 1. So all these 3 data member we can take it as an integer data member. So how we are going to define it? Let us see here. Struct card. The name that I will be giving is card. What is the member? Face numbers. To take that A1, A2, 3, 4, 5, we have this variable called face. Then it is followed by a variable called shape. Okay, shape can have either spade, heart in, diamond or clover. So 4 symbols, 0, 1, 2, 3, 4 shape. Then followed by color. Only 2 color, red or black, 0 and 1, 0 or 1. So 3 data member I'm having. What is going to be the size of this entire structure? This face will take 2 byte, this shape will take 2, and color is going to take 2. So together, if you just add all these things, you'll be allocating totally 6 byte of data. You'll be allocating totally 6 bytes of data for this entire structure called as card. Okay, fine. So now what we will do is, first of all, I'll just create one variable of this data type, struct card. So struct card is the data type, and I'll be declaring one variable called C, for example, one variable called C. How to define the value for, how to initialize the value? 2 ways of initializing. One in the declaration here itself. How we can do it? We have 3 member, right? For 3 member, we will give the values here. Face is going to be 1. Face is going to be 1. What is the shape? Shape is going to be 0. What is 0 shape? 0 shape is heart. Heart means definitely it will be red only. So red means 0. So 1, 0, 0. So what this is indicating me? This is indicating that we have taken a card, and that card is a red card, and it is having A on it. It is having A on it, and it is of heart in. It is of heart in. So we have taken a heart in A. We have taken a red color heart in A card. Okay, fine. So what if you declare this, what will happen automatically? A block will be created, a memory block will be created with 3 blocks like this. A cluster of block with the 3 independent blocks created like this, for example. Okay, you can see able to see. So 3 blocks are allocated, where the first block refers to face, and the second block refers to shape, and the third block refers to color. And the name given to this entire memory block is C. You can see here, card C. So the name given to the entire memory block is C, and you have 3 members there, and for the 3 members 3 memory block is created. And what is the value that you have given? 100. So what will happen here? Instead of face it will store 1, instead of shape it will store 0, instead of color it will store 0. Fine. If I need to access anything in this either of this 3 block, what I need to do? Variable name dot member name, variable date name dot member name, variable name dot member name. So you can either give c dot face, or you can either give c dot face, c dot shape, or c dot color in order to access it. Okay, fine. So now what is the next thing that we will do is that I will just introduce you to, or otherwise, see, if you can just declare like this, you can initialize the value here itself, or otherwise what you can do, c dot face is equal to 1, c dot shape is equal to 0, heart in. C dot color, if heart in is a shape, then definitely color has to be red, which is defined by 0. So either you can declare that way, or you can declare this way. Okay, now I'm going to convert this structure into array. Why I need to convert this into an array? Because if you see here, if you take a card, with one card you cannot play. You cannot play a game with one card. You need to have at least a deck of cards. What is a deck of card? A deck of card means it is a cluster of 52 cards. In this 52 cards, what you will be having? 13 cards in hearting, and then in diamond, if you see, in diamond you will be having 13 cards. What is this 13 cards? 13 cards means it is from A to K. A 1 2 3 4 5 6 7 8 9 10, J, Q and K. These are the 13 cards from A, not A1. It is A2 3 4 5 6 7 8 9 10 JQK. These are the 13 numbers. So 13 cards from hearting, 13 cards from diamond, 13 cards from spade, and then 13 cards from what is the one more we left? Clover. So together, if you add all this thing, you will have 52 cards. So totally a deck of card is equal to 52. These things you could have seen in mathematics. A deck of cards equal to 52 cards. So if I need to take 52 cards, what I have to do? I need to have 52 such variables. 52 such variables. How to have 52 such variables? Do I want to do like this? C1, C2, C3, like this. If I have to give to up to C52, no, this is not going to be a structure. This is not going to be an organized way of writing a code. Lines of code will be very large if you write like this. So instead of having 52 cards, instead of having 52 variables separately, what you can do, you can take the C1 for 52 times. So the same C, only one variable you have taken, so change it to 52. So now see, I told you that similar to integer, struct card is also a data type. So when an integer variable can be converted to an array, then your structure variable also can be converted to an array like this. So when you convert a structure into an array, what will happen? To show you here. So you are having a block like this, right? So instead of having a block like this, I'll just show you how this block will be created actually. Sorry, 1 minute. Fine. So now if you see, one block means it is okay enough, but if it is 52 means, you see here, the next consecutive blocks, the next consecutive blocks, the next continuous block, the next continuous block, it keeps on going like this. You'll be taking 52, you'll be taking 52 such kind of blocks. But in order to explain you, I'll just take only few of it and I'll show you how this is going to be stored inside. Okay, so I'm not taking 52 such blocks, I'm just taking 1 2 3 4 5. I'm taking only 5. So what is the how I will be differentiating, this is first block, this is second block, this is third block? It is similar to a array. When you take array, what will happen? First block is given index called 0, second block is given index called 1, third block is given index called 2. Similarly, this first block is given the index called 1, the second block is given the index called 1, third block is 2, next comes 3, next comes 4. So hereafter what you can do is that if it is first card, if it is first card means first block, which means C of 0. In C of 0, what you have to do? Color C of 0, color C of 0 means it refers to this first block, this 3 together. So this 3 together you have face, shape, color. So C of 0 dot face, C of 0 dot shape, C of 0 dot color. Similarly, C of 1 dot face, C of 1 dot shape, C of 1 dot color. So what you can give? C of 0 dot color is equal to 1, equal to 0. C of 0 dot face is equal to 1. C of 0 dot shape is equal to 0. So before we were using only C, now we have made it as an array and we are using C of 0, C of 1, C of 2, C of 3. So C of 0 is first card, C of 1 is second card, C of 2 is third card. Here it goes on up to 51, index number 51. So C of 51 will be the 52nd card. So you have taken 52 deck of card. You can ask me whether I will be able to initialize in this way. No, one more alternate way I will tell you how to initialize it. Open a curly braces here itself in the declaration line itself, and inside this, how I think totally 52 deck of card, right? For each deck of card you can have a set of curly braces for each and every deck of card, for example. So you can say this curly braces, this inner curly braces is first card, referring to first 0th card, this is 1th card, this is second card, and this is third card. So inside this, what you do is you give 1 comma 0 comma 0. Okay, next one is 1 comma 1. 1 means it refers to spade. Spade means the color is black, color black is referred by 1. Next, the card 1, but diamond, diamond is referred by 2, and if it is diamond, the color is red, red is referred by 0. The next card, I'll take ash, ash of it is going to be clover, clover is going to be black, clover is referred by 3 and black is referred by 1. You can keep on defining like this by giving 52 set of elements like this inside a curly braces. So you can keep on giving. This is in this way also what you can do. You can define the array of structures. Array of structures. So hope you understand this. So now what I will do is I'll just show you few. So I have now only taken 4 cards. I can leave the remaining part also. You know that in array itself I told you need not to allocate all the blocks. You can allocate few blocks also. For example, you can allocate 5 blocks. I have shown you this example. Int a of 5, and there is no necessity that all the 5 blocks has to be assigned now itself. I can give 1 2 3 and I can stop. 1 comma 2 comma 3 and I can stop. What will happen? First 3 blocks will be allocated this memory and the last 2 blocks will be automatically changed to 0. Similarly, here we will check what is going to happen. We will also, what we will do is we will just print f %d %d in order to print 3 members. C of 2. It is not first card, it is not 0th card, it is not first card, it is second card, this card. In this card, what I will do, I will just print all the 3 one. Face, followed by C of 2 dot shape, and then followed by C of 2 dot color. So now if you see this, we'll just we will just execute this and we'll just check. You see here, C of 0, C of 1, C of 2. The C of 2 data is being printed here. C of 2 data is being printed here. Now what I will do is I'll just show you the line by line traversal from the first line, very first line I will show you. Okay, I'll just show you the line by line process here. Okay, so see here, the straight away your execution came inside your main function. So main function is the starting point, it is the entry point. So automatically activation area is created for your main function, and you can able to see here you have created a variable called C, and how many blocks are there? 52 blocks you can see here inside. 52 cards have been taken, playing cards have been taken, up to 51. If you expand one card will be having 3 data like face, shape, color. All these 3 things are filled with some garbage value. You can able to see here. Don't think that this is 0. No, it is also garbage value. So you can see here, in everything you have some garbage value inside, because till now you have not declared anything. So now what I will do is we will just execute this 10th line. Just execute this 10th line, and now I will just expand and I'll check the 0th one. Here if you see, face 1, shape 0, color 0, the first one. Second card 3 1 1 1 1, it is displayed here. Then coming to 2 1 2 0, then followed by 1 3 1 will be stored in third index. Yes, 1 3 1. Now I will expand 4 and check 0 0 0. I'll expand 5 and check 0. I'll expand 6 and check 0 7. Now if you see, no garbage value is there, no garbage value is there. So once you at least declare only one set of card, all the remaining set of cards will be automatically changed to zeros. All the members of the remaining cards will be changed to 0. This is the same thing that I showed you in the array part. Okay, this is the same thing that I showed you in the array part. Okay, fine. So this is enough for the structure so far. Okay, so what we have learned is how to define a structure, like this. By taking many examples, we have defined the structures like this. Then how to find the size of the structure, then how to declare a structure like this: card C, card A, card C, card C1, card C2, some variable. So how to declare, then accessing member using the dot operator, how we have to access it. Then we have also seen character array also, structure array also, how to convert a structure variable into an array, that also we have seen. Initialization part also I have shown you. And also here visualization part, visualizing the same thing in the compiler also I am showing you. Okay, so this is enough. So for continuing further, this is enough. Okay, so what we will be doing is in the evening session. Okay, in the evening session we will start by clearing. Few people have asked me to explain the pyramid shape of the Pascal triangle, and I'll initially do that triangle in the evening session first of all, and then it will be followed by pointers. It's a very important concept, pointers. Without pointers it will be very difficult for everybody to move to the next flow. So don't miss the next video, just see it. I'll be explaining you about pointers very deeply. Okay, I'll be just explaining you about the pointers very deeply. Okay, so hope to see you in the evening session. Okay, thank you.